Yeah, good morning, students. Are you getting my voice clearly? Drop me a message if you are getting my voice clearly. Yes, Nana. Yes, I hope every one of you are getting my voice clearly. Right, as the weekend portion we have covered already, let us discuss few questions in this session. Few questions in this session. Some important questions are, can say some specifically speaking, some previous year's questions. We'll see. Yeah, actually, some of you have asked some questions yesterday, but I was unable to answer your questions, Nana, because of some reasons. Now, I will, after this session, I will try to send the answers for your questions. Okay. All right. Right now, just I will get a file here. One second, guys. One second. Right. So I hope you are able to see this. So electromagnetic induction. These are previous year's questions. Let us see few questions now from this. Yeah, in the previous years, just you can get some idea for that purpose. Just I would like to have a look at this. Already I have sent you guys in the group. You can go through that as well. Few questions, just few questions we will see. Yeah. this this file already I have sent in the group. You guys can open that and go through it and try to practice. Only a few questions are there, around 30 plus questions, 39 questions are there, and the key is also mentioned there. And if you have if you have any confusions in these questions, you can get back to me. All right, here you can see briefly some of the uh, let us see few questions here which are asked in the previous years. See, I think this concept of eddy currents we have discussed it, right? Is a simple concept. This based on this, questions are asked even in 2019. Also, a question is asked in the previous year, right? So if you observe here, in 1988, a question is asked from this. Then in 2019, a question was asked. So eddy currents. What are eddy currents are produced when? What are eddy currents? Eddy currents. We have discussed that whirling currents are circular currents produced in heavy metals, right? Due to change in magnetic flux. Due to change in magnetic flux, right? So if you see the options, you can understand, and you should be able to just select the appropriate option, right? So we can check. The first option says a metal eddy currents are produced when a metal is kept in varying magnetic field, metal is kept in steady magnetic field, circular coil is placed in magnetic field, a current is passed through a circular coil. Obviously, it produced in a metal, or I can say heavy metal, when it is placed in varying magnetic field, not in steady magnetic field, varying magnetic. So option A, you can check this. 23rd, 23rd, A, right? Yes. So this is what you can understand. Right? A metal is kept in a varying magnetic field. When a metal is kept in a varying magnetic field. So we can also observe here in which of the following devices eddy currents effect is not used. Not used. So you can see here options: electric heater, induction furnace, magnetic braking. What is it? Magnetic braking in train. You can say magnetic levitated trains. You can call them as in magnetic levitated trains. Brakes will be applied with the help of what you call the magnetic braking phenomena. So and the electromagnet. The question here is, which of the following devices eddy currents effect is not used? Of course, it will be used in induction furnace. Here, a big disc, metal disc will be used in induction furnace. So, in the heavy metal, of course, it will be used in induction furnace. Magnetic braking in trains. Yes, it will be used in magnetic braking of trains, like magnetic levitated trains. And electromagnet is a big magnet, huge magnet. So in there also we use a metal which will be magnetized by using the different phenomena. So electromagnet is a permanent magnet or a big magnet, so you can use this phenomenon in this way as well. But the electric heater, small electric heaters, this phenomena or concept will not be used. So option A is the appropriate answer for this one. Right. About this. Next, you see here question number 20. What is given here? Let me take uh, let me take the pen and the paper. 1 second. Right. Question number 20. Yeah. So what is given here? The magnetic flux through a circuit of resistance R changes by an amount delta phi in a time delta t. Then the total quantity of electric charge Q that passes any point in the circuit during the time delta t is represented by. So what is that? Question number 20. The magnetic flux through a circuit, I can say a coil, magnetic flux through a circuit of resistance R or a coil of resistance R changes by an amount delta phi. Flux changes by an amount delta phi in time delta t. Then the total quantity of electric charge that passes any point in the circuit, means what is induced charge is the question. We know whenever flux linking with a coil changes according to Faraday's first law, EMF induces. And according to what do you call it? Faraday's second law, the magnitude of induced EMF produced in a coil, which is whenever a flux linking with the coil is changing, here the flux is changed this by this amount, this time, then induced EMF is given by magnitude of induced EMF is given by delta phi by delta t or d phi by dt. And Lenz's law tells about its direction, so it gives sign, negative sign also. Here we are discussing about magnitude. And if this coil is having some resistance, this coil or circuit is having some resistance, we have also discussed that an induced current I, which is equal to E by R induces, is equal to 1 by R into E is delta phi by delta T. Current induces in the coil. This is induced current in the coil. Whereas induced charge is given by I is equal to, from the definition of current, we know as I is equal to dq by dt or q by t. Instantaneous current q by t. So from this q is equal to I into t, I can also write it as dq by dt or delta q by delta t also we can represent. So dq is equal to I dt or q is equal to integral of I dt. Integral of I dt. So integral of I here we can express this as what is this? I simply can say dq is equal to dq is equal to I into dt is equal to I is, or if you want to write it is a finite value, average value, phi delta phi, finite value, delta t is a finite value. You can take phi by t also. Okay. So if you take this dq equal to I dt, where I is this, I is what? 1 by r is delta t. So this gives what? This gives, if delta t cancel, 1 by r into d phi or delta phi. So the total is expressed as the amount of charge. You can take it as q is equal to 1 by r into delta phi. Yes, here by definition d phi dt, d phi dt smaller values, and here if you take this is d phi by dt gets cancelled, then you can say dq is equal to this 1 by r into integral of d phi, or integral of dq is equal to 1 by r into integral of d phi you can take. So q is equal to 1 by r into, where phi changes from 1 by r into integral of d phi is phi with the limits phi 1 to phi 2. So it gives delta phi, and you can take it as phi 2 minus phi 1. You can take it, I can also take express this as delta phi by r also you can take. This is induced charge, right? So q is equal to 1 by r into delta phi is the, which option is that, or delta phi by r? Option B. Question number 20, option B. Option B. What is that? 20. Option B is right. Right? So likewise we can work out few questions. Few questions. And here let us see question number 19. Question number 19. What is given here and what you are asking to find? In a coil of resistance 10 ohm, the induced this is, but this is JEE mains 2012 question. But this kind of questions are important, I told, right? So try to have a look at this. If at all this kind of questions asks, you should be able to answer this. So what is given here? In a coil of resistance 10 ohm, the induced current developed by changing magnetic flux through it is shown in figure as a function of time. Induced current developed by changing magnetic flux through it is shown the figure as a function of time. So current time graph is given. Induced current time graph is given. The magnitude of change in flux through the coil in Weber is, the magnitude of change in flux through the coil in Weber is what? So how to consider this? It is here it is given the induced current I in ampere, means it is in SI unit, versus time t in seconds is given here. If this at time t equal to 0 is having maximum current of 4 amps, and as time changes it decreases and becomes 0 at a time of 0.1 seconds. Then by using this, how to find the change in flux? Right? Already we have discussed. What is that? From IT graph. IT graph. What is the area under IT graph gives off into base into height. I into T gives what? Here it is, one more thing is given here. You can I have to understand this. In a coil of resistance 10 ohm induced the current versus time graph is this. So just now we have discussed one relation here. You see, we are asked to find here what? Flux in terms of current, right? Flux in terms of current. But we know current is, induced current is equal to E by R, or 1 by R into d phi by dt. d phi by dt. So from this what you can write it is, here is d phi is equal to IR dt. IR dt. So try to make use of that relation here. As we know, I is equal to E by R, or it is equal to 1 by R into E is magnitude of E is d phi by dt. So 1 by R into d phi by dt. From this we can write, we are asked to find actually change, the magnitude of change in flux through the coil. So from this we can say change in flux at d phi or delta phi is equal to I R dt. IR dt. Let us say this is equation 1. But from the graph, area under IT graph gives area is equal to, it is in the form of a triangle, so half into base into height is the area, half into base is a time, that is 0.1, height is current. Actually here you can take like otherwise t into I r is equal to half into I into t. I into t is area, here I dt. So integral of d phi is this. So for integral of phi from limits phi1 to phi2 gives phi is equal to integral of I dt is t. So it is nothing but what? Area, that is here is what? So this IR, R into area I can write. So from this you can say uh, it is equal to change in flux, take it, d phi is equal to R into I dt. I dt is, you can see area is proportional to area under this. This is area. So of course that means twice the area. I dt is nothing but delta I by delta t is nothing but. So you can say it is proportional to area, proportional to area. So that area if you find out and if you substitute here, you will get what is that change in flux. Yes, if you guys are following this, try to calculate it and find out. So I hope you got the answer. You try to copy it, don't just simply listen guys, try to copy and do the simplifications part. I said I have given you this already, this document, you guys can go through this as well. So question number 19, question number 19, right, 19b, question number 19b, that is change in flux will be 2 units, 2 Weber is the answer, and simplifying this we get it will be 2 Weber. So this is how you have to work out this kind of questions. Got it? Next, let us come from few questions here from the starting. Yeah, I see here magnetic flux. Let's see the question number 1. Question number 1. Question number 1. So what is given here and what you are asked to find? It is given that a circular disc of radius 0.2 meter, circular disc, a circular disc of radius r is equal to 0.2 meter is placed in a uniform magnetic field, is placed in a uniform magnetic field of induction B is equal to 1 by pi Weber per meter square, Weber per meter square, or Tesla. Magnetic field unit can be taken as Tesla, right? In such a way that its axis makes an angle of 60 with magnetic field. Circular disc, this is a circular disc. Its axis will be a line passing through center and perpendicular to the plane. So this is making an angle of 60 degree with the magnetic field. So magnetic field is not parallel. So magnetic field is lying somewhere like in this direction. Then this is magnetic field. This is area. Or if magnetic field is horizontal, then area have to take taken like along accordingly. So that this will be theta is equal to 60 degree. So what is this here? You have to be carefully understand this point only. Here only what do you call it? This will be given in the questions. Many of you guys will confuse here. Okay, uh, such a way that axis makes an angle 60. Usually area will be along the axis. Area will be along the axis. So angle between area and magnetic field is 60. Then magnetic flux linked with the disk is what? Magnetic flux linked with the disk is what? Just is it a simple one? Only you should understand the given data properly. That's it. So flux phi is equal to B A cos theta. Here what is B? 1 by pi. What is A? Radius is given. So area will be pi r square. R is 0.2. Square is 0.04 into pi. Or it is pi into r square is 0.04 into cos theta is 60. So pi cancel 0.04 into cos 60. Cos 60 is 1 by 2. So it is 0.02 flux in Weber. So which option is the right one? So first question. First question. Right. Option C. Option C. S 0.02 Weber. Right. Sometimes actually I have observed that for few questions options are also given wrong. Here there means some printing mistakes also are there. Be careful guys. Some printing mistakes are there. So be careful. So if you listen, now you can understand in some of the questions. You can cross check that also. Next question number 2. Question number 2. What is given here? A 800 turn coil of effective area 0.05 meter square is kept perpendicular to a magnetic field. Is kept perpendicular to the magnetic field of 5 10 power minus 5 Tesla. When the plane of the coil is rotated, as guys, is there any questions? Anyone has mentioned anything in the WhatsApp? Sometimes you will not observe. Oh. Sir, little louder. Okay, sir. Okay, fine. Yeah. I will. Yes. One second. One second. Let me. I hope you guys are getting the voice clearly. Yes, everyone. Right, just you can respond if anyone is not getting the voice. Also, just you can respond in the chat box so that usually I won't check the WhatsApp. So just now I have checked it, so that I came to understand. Otherwise, if you mention in the chat box, I can understand that students, right? Right. Okay, Nana. Okay, fine. Yeah. I hope now you guys are getting little more louder and more clearly also. Right. So next, let us see question number 2 quickly. Question number 2. Question number 2. Right. So the question is, a 800 turn coil of effective area 0.05 meter square is kept perpendicular to a magnetic field 5 into 10 power minus 5 Tesla. A 800 turn coil. So number of turns in the coil is equal to 800. At 800 turn coil of effective area A is equal to 0.05 meter square. So you can also write it as 5 into 10 power minus 2 meter square. It is given in SI units only, no need to convert. Right. Is kept in perpendicular to a magnetic field of effective area is perpendicular to magnetic field. What does it mean? Area is perpendicular to, what is that, 800 turn coil of effective 800 turn coil of effective area. This is kept perpendicular. Coil is kept perpendicular.
You have to be careful about here. Coil is kept perpendicular to the coil having effective area. This is kept perpendicular to the magnetic field means initial angle theta is equal to 0. Area vector will be parallel to magnetic field. When coil is perpendicular to the magnetic field means area will be parallel. So theta 1 will be 0. Right. This is kept in a magnetic field of magnitude B is equal to 5 into 10 power minus 5 Tesla. When the plane of the coil is rotated by 90 degree, when so let me uh, yeah, right guys. When plane of the coil is rotated by 90 degrees. So initially, so this is the direction of magnetic field. Let us say the magnetic field is acting in horizontal direction. Plane is perpendicular. Plane is perpendicular. So the area of this plane is in this direction, that is in the direction of magnetic field. Both are parallel, so theta is 0. 0. Now this is the plane. Now it is rotated through 90 degrees. So the plane is rotated through 90 degrees. This is the magnetic field. So now it is the area. Its area vector will be in this direction. So angle between field and area vector will be 90 degrees. So theta will be 90. Theta 2 we can say is equal to 90 degrees. Theta 2 is equal to 90 degrees. So what is mentioned? The plane of the coil is rotated by 90 degrees around any of its coplanar axis in 0.1 seconds. So to rotate this, it has a time taken to do this process is 0.1 seconds. Then EMF induced in the coil will be EMF induced in the coil will be what? EMF E is equal to what? We know that EMF induced is equal to change in flux by time d phi by dt. If it is the coil is having n number of turns, okay, the flux can be given as flux where flux phi is equal to ba cos theta. If it is having n number of turns, n b a cos theta. Here b and a are fixed magnitudes, n is also fixed, so you can write it as n b a into you can say it is theta is changing. You can write it as d theta by dt at delta phi, d phi by dt at delta phi by delta t. That is phi 2 minus phi 1. So NBA is constant. Phi 2 will be cos theta 2 minus cos theta 1. That is divided by dt or delta t. You can take delta t is given as this much. You can also write it as delta phi by delta t. Right now. This is equal to calculate, do the substitute the values given and simplify it. N number of turns 800, 8 into 10 power 2. B 5 into 10 to the power minus 5. Area 5 into 10 to the power minus 5. Cos theta 2 minus cos theta 1. Theta 2 is 90. Cos 90 is what? Actually by what is Faraday's law, it is minus equal to minus d phi by dt. So minus. So here minus. So it is equal to here also minus. This into this into this. So here cos theta 2 is 90. Cos 90 is 0 minus cos initial value is theta 0. So cos 0 is 1 by delta t. Delta t is what? 0.1 means 1 into 10 to the power minus 1. 0.1 can be taken as 1 into 10 to the power minus 1. Now on simplifying, what we will get here 0 minus 1 is minus 1. Minus 1 into this minus becomes plus. So we will get induced EMF. This is induced EMF. Because of this we'll get this one. So induced EMF E is equal to what? Right. Yes, you can simplify. 10 power minus 1. 10 power minus 1 cancel here. Minus 1 will be here. And plus 2 minus 5 becomes minus 3. Minus 3 1 minus 4. So here 8 5s 40. 40 into again 5. 200 into 10 to the power minus 3 minus 1 minus 4. So which option? You can say 2 into 10 power minus 2 volts, or you can take it as 0.02 volts. So question number 2, which are options are given in decimals, 0.02 volts. So you can also write it as 4 decimals means 10 power minus 4, 4 decimals. If you shift to left side, you will get 1, 2, 3, 4, 0.02 volts is equal to 0.02 2 volts. Options are given in decimals, so you have to do this one, otherwise accordingly you have to simplify it. So option A, question number 2, option A. Option A, yes. Got it? Right. Next, question number 3. Let us see. This is a simple question, but this is a kind of important question. It is NEET Phase 2 2016 question. 2016 NEET question it is. So what is given here and what you are asked to find? The one which I have just now is 2019 NEET question. Okay. So it is question number 3. What is given here? It is given that a uniform magnetic field is restricted within a region of radius r. The magnetic field changes with time at a rate of dB by dt. The loop 1 of radius capital R, you see here, a uniform magnetic field is restricted within a region of radius small r. So this is having small r here, it is mentioned here, see, this is small r. This loop is having a region having radius small r. Okay, is restricted within a region of radius r, small r. The magnetic field changes with the time at a rate of dB by dt. Okay, so it is not uniform field, variable magnetic field. Now the next point is loop 1. So this is loop 1. This is loop 1 of radius capital R encloses the region small r. This encloses the region small r, and loop 2 of radius capital R, there is another loop 2 of same radius capital R which is outside the region of magnetic field as shown in figure. Then the EMF generated is what is EMF? You know, EMF is nothing but by definition E is equal to minus d phi by dt, minus of change in magnetic negative rate of change of flux with time. So where if the coil where flux phi is nothing but NBA cos theta. NBA cos theta is angle between magnetic field and area vector. If the loop is this, its axis or perpendicular will be normal will be in the direction of the magnetic field, there will be parallel. So theta is 0, cos 0 is 1. For if the loop is having one turn, n is equal to 1, this is equal to 1, so you will get BA. Phi will be equal to BA. Now if you bring it here, then you can write it as minus d by dt of B into A, but it is a circular flux. The magnetic field is changing here in this region of radius small r only. So in which area magnetic field is changing? In which area? So area in which magnetic field changing, so that magnetic flux also changes here. It is given in this area of pi small r square. So it is equal to flux linking with this coil in this loop is due to change in magnetic field in this loop. So in which loop of the loop of a radius r, so you can write it as B into area of this loop is B as pi r square. So it is equal to B into A or pi r square. So here B is variable here, but R is constant. Because of change in this B with time, the flux is linking with it, so and hence EMF is generating. So it is equal to minus pi r square. If you take it out, you can write it as pi r square into dB by dt. This gives the induced EMF. So then the EMF generated is in this loop, that is in loop 1. Here if you say loop 1, induced EMF is minus pi r square dB by dt. So minus dB by dt pi r square in loop 1, minus dB by dt pi capital R square in loop 1, minus dB by dt pi r square in loop 1. Loop 1 is minus dB by dt pi small r square, is correct, but it is wrong. Okay, and 0 in loop 1, no, it is wrong. Then what about loop 2? This is loop 2. In loop 2 there is no flux linking here. This is perpendicular here, so it is not, no way it is connected or linked with this. So no flux is linking with this. So here it is a flux linking with the second loop is 0. So EMF linked with this is also 0. So you can say so loop 1 is 0 and 0 in loop 2 also. So it is wrong. So here minus dB by dt. So minus dB by dt pi r square in loop 1 and the same value in loop 2 also mentioned. So it is wrong here. So 0 here minus dB by dt pi capital R square in loop 1 and 0 in loop 2. 0 in loop 2 okay, but it is not capital R square. It is a small r square. So this is also wrong. So here it is minus dB by dt pi small r square in loop 1 and 0 in loop 2. This is correct. This is correct. So if sometimes maybe the because you are considering this with signs, if sign is given as positive, then you have to be careful about that. Means the direction will be changed. The direction of induced EMF will be changed. That is the meaning of the sign. So then also you have to be little careful. If in one option is minus dB by dt minus dB by dt pi r square is in loop 1, 0 in loop 2 is given here, plus dB by dt in pi r square and in loop 1, and another one is also 0 only given, but depending on the signs you have to you have to verify this. So in such cases you have to be little more careful if signs are given and specifically. Next, question number 4. Let us see here. What is given here in question number 4? It is given that a coil of resistance, to question number 4. It is given that a coil of resistance R is equal to 400 ohm is placed in a magnetic field. If the magnetic flux phi in Weber linked with the coil varies with time t as phi is equal to 50 t square plus 4, then the current in the coil at t equal to 2 seconds is what? Current in the coil is what at t is equal to 2 seconds. So resistance is given, flux as a function of time is given. Then how to find current? How to find current? We know that induced current. Induced current is induced EMF by resistance. What is induced EMF? d5 by dt. That's it. So only the magnitude part if you consider. As we know, I is equal to what? D induced EMF by resistance. It is equal to 1 by R into only magnitude part if you consider. Okay. And where what is this? E induced EMF. Induced EMF is d5 by dt. So it is into d5 by dt. So it is I is equal to 1 by R into what is phi is this? d5 by dt means change in phi with the time. So if you differentiate with the time, directly you can take it as it is 50 into t square. Differentiation of t square is 2t. Here it is a constant. Differentiation of this is 0. So it is 50 into 2t becomes 100t. So you can write it as 100 t. 1 by R into 100t is induced current at any time t. But specifically at time t equal to 2 seconds, what is current you are asked to find? So at t is equal to 2 seconds, I is equal to into 200 by R value is given as 400, so it is 200 by 400 is equal to 1 by 2 ampere. 1 by 2 ampere is the answer. See here 1 by 2, oh, they have given in 0.5 2 0.5, it is not 1 by 2, 2, so it is not correct. 1 by 2 means 0.5, so you have to take it as 0.5 ampere. 0.5 ampere, that's it. Right, next, question number 5. You see here, question number 5. So what is given here and what you are asked to find? It is given that a conducting circular loop is placed in a uniform magnetic field B. Uniform magnetic field B is conducting circular loop. Conducting circular loop. You have to keep you should keep these points also in mind. Conducting circular loop is placed in a uniform magnetic field of induction B is equal to 0.025 Tesla is an SI unit, no need to change, with its plane perpendicular to the loop. So with its plane perpendicular to the, what is that? With its plane perpendicular to the loop. Whose plane? Conducting circular loop is placed in uniform magnetic field of this much this Tesla, whose plane is perpendicular to the loop. Means plane of the magnetic field is perpendicular to the loop. Means perpendicular to the plane of the loop, or it will be parallel to the area. That means you can say that the angle between them should be 0. Angle between area vector and magnetic field vector will be 0. Now the radius of the loop is made to shrink at a constant rate of 1 mm per second. What does that means? Radius of the loop made to shrink means it is made to change. Yes, now it is reconnected. I hope you guys are getting the voice now clearly after reconnection. Yes, can someone drop a message if you are getting the voice clearly? Can someone drop me a message if you are getting the voice clearly? Is it reconnected, or still you are getting, what is that, buffering? Are you getting the buffering symbol, or are you getting clearly? Someone respond. Someone respond. Yes. Okay. I hope it is clear for you guys. And I would like to put a point here that now how many are there? Around 9 members are there. Now it's okay. Yes. Thank you, Nana. Thank you. Uh, those who are in the session now, can you respond? How many have already registered for the NEET? If you need any help in that, what are the things and how to do it? Just I can give you some clarity about how to make the things, and how before registration you guys have to keep few things ready first. Already you guys know it. Still, I am repeating that. Some of the things you have to keep it ready, um, like scanned, especially scanned copies, and even your 10th class mark sheet you should have, and the scanned copy of that at one point you have to upload, and marks also you have to upload in under academic details. So both are required. Some of you guys have asked earlier, so that's why I'm giving you this information now. So I may try to give you some information regarding how to fill this and what are the things we have to be careful. One of the I will try to take some half an hour, and afterwards in the evening I will explain. If some of you have already finished the process, it is okay, well and good. Otherwise, just you can go through so that it may be helpful for you guys. Right. Right. Okay, let us go ahead with this now. And if you need any clarity regarding the application process, you can drop me a message as well. Right. Yes, so let us go ahead with this question. Now, what is given here is the rate of change of radius. That means the loop is shrinking at the rate of 1 mm per second. Means it is the rate of change of radius. It is 1 mm per second is equal to 1 into 10 power minus 3 meter per second. Meter per second. This is will be the SI unit of this. Next, if so, what should be, guys? Still, any other session is going on for the long term, guys? Is already completed, right? I hope it is completed already. Right. Yep. Okay. So the rate of change of radius is given as 1 mm per second, and induced EMF when the radius is 2 centimeters is, when the radius is 2 centimeters, when R is equal to 2 centimeter, that is equal to 2 into 10 to the power minus 2 meters. What is induced EMF in the loop is the question. So to work out this, it's the same. The relation of EMF you have used. What is the EMF? E is equal to d phi by dt. D phi by dt. Magnitude only if you want. Otherwise, you have to take with the negative sign. Okay, only magnitude is E equal to d phi by dt, where phi is equal to NBA cos theta. NBA cos theta. It is mentioned that here it is the plane is perpendicular to this, so theta is 0, cos 0 is 1. Directly can take, and only one loop is given, so n is equal, n also you have to take it as equal to 1 only. So NBA will get d by dt of B into area. So as n equal to 1, theta is 0, so cos 0 is 1, so you can take it as BA. And BA is fixed here. As radius is changing, area will be changing. How to represent this is that you have to take this as B into d by dt of area. Area can be taken as d by dt of pi r square. So this here pi is constant. If you take this as a pi into B, and if you differentiate this r square, you will get 2r dr by dt. So pi into 2br into dr by dt you have to take. Dr by dt you have to take. So in this one here, what is this is EMF. Now pi 2 pi br, you can write as 2 pi br. B is given R is given. At this radius, what is EMF induced is you're asked to find. So that rate of change of radius is this. So substituting all these values. What are these values? It is equal to 2 into, if you observe the options, if the options are given in decimals, you have to substitute all the values, even pi value also, otherwise you have to accordingly have to substitute. So question number 5, so they have given in terms of pi, so pi you are not supposed to substitute, and mu, micro, the V is volt, unit of EMF is volt, so it is given as 2 pi into B is 0.025, or you can write it as 25 into 10 power minus 3, 25 into 10 power minus 3 into R is 2 centimeters, 2 into 10 to the power minus 2 into dr by dt is 1 into 10 to the power minus 3. These are the given values. If you substitute these values and simplify, you will get in terms of pi, 25 into 2, how much? 50. 50 into 2, 100. 100 means 10 power 2. 10 power 2, 10 power minus 2 will cancel out. Then what remains here? 10 power minus 3, 10 power minus 3, 10 power minus 6. Pi into 10 power minus 6. Pi into 10 power minus 6. What is that? EMF induced volts. This 10 power minus 6 volts can be expressed as E equal to pi microvolts. Oh, that's it. Pi microvolts. Microvolts is the answer. So we have to take it accordingly. So what is the option here? Pi microvolts. Question number 5. Option B. Pi microvolts. Option B. Fifth question. Option B. Fifth one. Yes, option B is the right one. Yes. So likewise, just you guys have to work it out. And this question is again one of the very important question. It is also previous year. These are all previous years, of course, new questions. So there are some of the questions are from mains also they have taken. So this question and this question, similar kind of questions. So here again here 2010 this question is asked. 2009 also similar kind of question is asked. If you observe here, you can realize that. So a conducting circular loop is placed in a uniform magnetic field of 0.04 Tesla with its plane perpendicular to the magnetic field. The radius of the loop starts shrinking at 2 mm per second. The induced EMF in the loop when the radius is 2 centimeters is. The radius is same, and this values, of course, the rate of shrinking is changed. So similar kind of questions asked in other year also. So this kind of questions are important, guys, to keep that in mind and practice. And if you see question number 6, this is kind of very little interesting one. So it is given that a rectangular, square and circular and elliptical loops all in xy plane. XY plane, you can take horizontal plane or vertical plane for your paper. On the plane of the paper, you can take it as xy plane, are moving out of the magnetic field. The constant velocity of v vector equal to v I cap means they are moving out of the field along positive x direction. They are moving out along this positive x direction. That is the meaning of it. The magnetic field is directed along the negative z direction, means into the plane of the paper. Let us consider. Then induced EMF during the passage of these loops out of the field region will not remain constant for which of the following? That means will not. What is that? Induced EMF during passage of these loops. Passage of these loops out of the field, when the loops are coming out of the field, will not remain constant. Induced EMF will be constant for few loops, but for few loops will not be constant. What are those loops is the question here. Question number 6. Question number 6. What you have to understand here is question number 6. There is a uniform field. It is getting directing into the negative z direction. Let us say negative z direction is into the plane of the paper, into the plane of the board. So here we have different what do you call structures. Rectangular structure and square structure and circular structure. Disconnected, reconnected successfully. Okay, fine. Right. E is equal to d phi by dt, where phi is equal to NBA cos theta. So I can write this as d by dt of NBA cos theta. NBA cos theta. Okay. Now here N1 cos theta, I can take it as, of course, cos theta is 1 out, B is uniform out, area is changing, so d by dt of area I can take. So d by dt of area, if you consider when it is moved, depending on how it is varying, EMF induces. If it is varying uniformly area, then EMF induced will be uniform, otherwise not uniform. That you have to understand. So if you consider first rectangle and square, when it is moving out, when it is moving out, so this part of length will come out, let us say uniform, it is moving with uniformly velocity means a constant velocity, so equal distances will be moving per unit seconds. So when this is the distance covered in unit time, of course this part will be fixed anyway. Let us say this is L into B will be fixed here. This, if it is x, every 1 second x equal values of x will be covered. So area which is decreasing here will be equal, and hence uniform in E will be uniform. E will be induced EMF will be uniform in this case. Same thing will happen in this case also when it is trying to coming out. So equal this distance x, and because it is anyway, if you take it as L into L, this will be some x. As x is varying uniformly, then you can say E is equal to uniform in this case also. But in this case, when it is coming, when it is trying to come out, so here a part of this area may come out. Next, a part of this area may come out. This, because the structures are differing, areas will differ. So E will not be not uniform. E, because area is not uniform here, E is equal to non-uniform because dA by dt is not equal to constant, So, and similarly in this case also it will happen. In case of ellipse also, E will here the area covered will be different because of this. Here this is small, different area will be coming out. Here different area will come out, different area will come out. Not like this uniform areas. So this also here also area is not uniform. So induced EMF will be non-uniform. So in these two cases, induced EMF will be not uniform. In the other case, it is uniform. So question number 6. 6 only. Yep. That's what you can understand from this. Question number 6. The question is, induced EMF during the passage of these loops out of the field region will not, what is this? Will not uniform for, will not remain constant. Uniform for which ones? Circular and elliptical loops. Only elliptical loop, only circular, any of the 4 loops, the rectangular, circular and elliptical loops. So it is uniform rectangle for a rectangular and square. Only for circular and elliptical loops it is not uniform. So question number, option A is the right one for this particular question. Okay. So this kind of questions you have to be you have to understand it carefully. Let us see here one interesting question which I would like to make you guys to work out here. Question number 11, based on Lenz's law and conservation of energy. Based on Lenz's law and conservation of energy. See here. An electron moves on a straight line path xy as shown. The ABCD is a coil. Adjacent to the path of electron. The ABCD is a coil adjacent to the path of the electron. ABCD is a coil adjacent to the path of electron. This is the path of electron. Electron is moving along a straight line path xy. Right. Fine. ABCD is a coil adjacent to the path of electron. What will be the direction of current if any induced in the coil? What will be the direction of current if any induced in the coil? To understand this, you have to just recollect back the concept of what Lenz's law. This is based on Lenz's law and the conservation of energy. Okay. We already discussed that Lenz's law is a consequence of what? Conservation of energy. Of course, Lenz's law is also a part of Faraday's law. I can say Faraday's third law. That means Faraday's laws also, Faraday's first law and Faraday's second law can also be termed as, they are also based on law of conservation of energies only, not only Lenz's law. Lenz's law and Faraday's laws all together are based on law of conservation of energy. Right, if you observe here, when electron is moving in this direction from x to y, we know just a few concepts you have to interrelate here. When electron is moving from left to right, the direction of current will be the conventional direction of current will be then the opposite direction to the direction of passage of electrons, right? So current will be in this direction. Current will be actually the direction of conventional direction will be opposite to the direction of electron, so current will be in this direction. When current is in this direction, like if you consider the what you call right hand thumb rule, if you stretch the thumb in the direction of current, and if you curl the fingers will go into the plane of the paper for the coil ABCD. So magnetic field will be into. So as the what you call electron is approaching, you can say when it is moving from x to y, and as it is approaching the point C or midpoint, the point C or midpoint of the point C is nearer to the midpoint of the straight line path xy, right? When it is approaching the midpoint of this path xy or approaching the point C, current will be, as distance is decreasing, magnetic field due to current coil already have discussed, right? Magnetic field due to current carrying coil, infinite current carrying coil is mu naught I by 2 pi r, or mu naught I by 2 pi r due to infinite coil. So here mu naught I by something, some value, as r, this distance will be in what you call reciprocal. So as r decreases, magnetic field will increases. As magnetic field increases, induced current will increases here. So when it is moving closely, induced current will be increased due to change in magnetic flux. Induced current increases, so that will be in the direction of. So in what direction? Induced current will opposes the direction of motion of this current. So let us say, so that usually the magnetic field due to this will be moving charge will be into the plane. So the induced current should oppose this, means that should create. So it is into the plane means an outer face south pole will be there actually, but due to induced current to oppose that also should what you call induces south pole. Now when it is moving away, as distance decreases, the current, and hence what you call as distance decreases, the magnetic field strength will decrease. As it decreases, it tries to oppose that. Induced current should oppose that. So to oppose it, the direction of induced magnetic field, and hence induced current should reverses its path. So the current will reverses its direction as the electron goes past the coil. Past the coil means when it crosses the coil. This is what you can understand, right? As the time up, I am winding the session now. You guys can go through few more questions. Try to go through all the questions in the previous year's part, so that you can get an idea. So already these few questions are the previous year's questions are there in our volume also. These questions already have discussed, like question number 16 and all we have discussed already. So you can understand those things and try to follow it. Now I am winding the session. Okay, take care everyone. Bye bye. And those doubts which I have already mentioned, I will send you once again. Okay. If you have still if you having any doubts, you can send me, so that I will record and I will send you back those